Algebra 3, welcome to lesson 69. First, we're going to talk about matrices or matrices. A matrix is an array of numbers written in rows and columns, and they're grouped together sometimes with brackets, sometimes with just lines, sometimes with nothing at all, but they're in rows and columns on purpose. That is what's called a matrix, and I know that if you've taken the ACT, you'll probably have seen at least one matrix problem. So usually a matrix is enclosed in brackets. That's how we're used to seeing them. Very rarely do we see them without anything around them. Every now and then you'll see it like this, but this with the bracket is going to be the most common identification of a matrix. Now, a matrix is named by the number of rows and then the number of columns. So this would be a 2 by 2 because it has 2 rows and 2 columns. This is a 2 by 3 because it has 2 rows and 3 columns. And this is a 2 by 5 because it's got 2 rows and 1, 2, 3, 4, 5 columns. So you can see that it has a specific naming function or feature. You cannot just name it 5 by 2 because then that would say, well, it's got 5 rows and 2 columns. No, you have to do the rows first and then the number of columns. It's kind of like reading from left to right. You read what's on the left first and count how many rows, and then you count to the right how many columns. So it kind of makes a little bit of sense if you think about it in terms of left to right in reading. Now, another thing that's important to remember about matrices is that if they are not identical, they are not equal. So this matrix here with 4, 1, 2, 5 is equal to 4, 1, 2, 5. But this matrix with the same 4 numbers, they're not arranged in the same way, then they are not equal. The numbers have to be arranged in the same way in order for them to be equal to one another. So that is something to look for whenever you're evaluating matrices. Look for identical placement of the numbers, not just having the same numbers. And there's a reason for that. And that is going to be the determinant. The determinant is a calculation that you use to evaluate the matrix. So let's talk about the determinant next. So determinants are something that you can only get with a matrix, and it must be a square matrix. So 2 by 2, 3 by 3, 4 by 4, etc. They have to be the same number of rows and the same number of columns in order to have a determinant. And a determinant is found by multiplying at the diagonal from the top left corner down to the bottom right corner. That diagonal is going to give you a positive determinant. From the bottom left corner up across to the upper right corner, you're going to get the negative determinant. And that's going to give you the value of a times d minus c times b. And that can be for a larger matrix as well. What you need to remember is that multiplying from the top down to the bottom, from left to right, is going to give you the positive, and from the bottom up to the right is going to give you the negative. So if you think about our Cartesian coordinate system, it's the opposite. The angle of the line that goes up is usually positive. Here we have negative. And usually down is negative. Here it's positive. So to kind of give you a better illustration of that, I'm going to erase this and do it again. And I'm going to do it like this. Erase this right here. So picture the United States, right? If you have your determinant, let me switch over to the white so you can see it a little bit better. If you have your matrix, you have A, B, C, D, right? If you put that over a map of the United States, and we go from the bottom up, let me get the blue back, from the bottom up, that's going to point to the north or the colder temperatures in the United States. And if you go from the top down, that direction, that cross multiplication, you're going to point to the hotter temperatures of the United States. If that helps you, if that mental picture helps you remember how matrices work, then that is what I want to do for you. I want you to see that illustration to kind of remember the process. But it's always going to be the positive and then the negative. You're always going to have AD minus CB. So that is why I use those colors also, is to help you remember hot minus cold, right? So hot is positive and cold is negative, so we subtract it. So that is how we do determinants within matrices that are square. So we have 4 practice problems. I'm going to clear the board and let's put them up here. So in our first practice problem, we have negative, it's a 2 by 2, and that's all of these. We're all just going to 2 by 2s for right now. We have -4, -3, 2, and 7. So first we come from the top down to get our positive, and that's going to be -4 times 7. And then we go from the bottom up to get our negative, which is going to be 2 times -3. So now we just do the math. This is going to be -28 minus -6. So that is going to equal -28 plus 6, which is going to be -22, is going to be our answer. So we do not change the sign so much as we subtract this side from this side. All right, this is our minuend and this is our subtrahend. That's the way it works. Okay, I hope that makes sense. Let's do another one. Give me just a second to put it up here. So here we have to evaluate -7, 5, 3, and -4. So we're going to start from the top down, like this. So -7, -4, minus, and from the bottom up, 3 times 5. So that would be +28 minus 15, which would equal 13. It's just simple multiplication and then subtraction. You guys can do this in your sleep. It's super, super easy. I'm going to put the last 2 problems up here for us. So now they're starting to get a little bit more complex, right? So we can see where they can throw some wrenches in what we're used to without it being numbers. Now we have to do a little bit more calculation in here. So here we have the top to the bottom. That's going to be 4 times x plus 4 minus, and that'd be 2 times 3. We know that that is 6. So we're just going to leave it like that. So now we're going to find x. And the way we would find x is by, oh, I'm sorry, I left out a part, equals 18. So equals 18. I didn't write it all the way up there. All right, so then we would just solve it, right? So 4x plus 16 minus 6 equals 18. So 16 minus 6 is 10. So if I subtract 10 from both sides, I get 4x is equal to 8. X is equal to 2. So it's all about setting up the equation and solving it like you normally would. So let's do the last one and then we'll be done. So here is our final problem. We have the matrix x plus 4, 5, 3, and x plus 2. And again, we're just going to do the same process from the top to the bottom. That's going to be x plus 4 times x plus 2 minus 3 times 5 would be 15 is equal to -5. So now we just solve. So this is going to be x squared. And then we're going to have 4x and 2x, so that's plus 6x plus 8 minus 15 equals negative 5. So if I add 15 to both sides, that goes away and this becomes a positive 10. And then if I subtract 8 from both sides, this becomes a positive 2. So that would be x squared plus 6x equals 2. So I am going to, let's see, what should I do to solve this? I am thinking that from here, I don't think that we can factor this. So I believe that we're just going to bring this back over. X squared plus 6x minus 2 equals 0. And we're going to use the quadratic formula because it's faster. X is equal to negative 6 plus or minus the square root of 6 squared would be 36 minus 4 times 1 times negative 2. So that would be positive 8, which would be positive 8 plus 36 would be 44. All over 2 times a, which would be 2. All right, so let's see if we can reduce this. Well, I know that this is 4 times 11, right? 4 times 11 is what 44 is. So I can bring that 4 out and make it a 2. So then this would become 2 times the square root of 11. And everything here is divisible by 2. So x would be equal to negative 3 plus or minus the square root of 11. And that is correct. That's our answer. So not every time you do a matrix, you're not always going to get a nice little answer, just like every other equation we have ever done. Sometimes the answer is easy. Sometimes it's more difficult. Sometimes it's complex. Sometimes it's imaginary. But it's going to be whatever it's going to be because that's just math. And that is all we have for lesson 69. It's actually kind of fun when you start playing around with the bigger matrices. And now that you know how they work, seeing them on the ACT is going to be easier for you to do. And you'll go, oh yeah, I know what to do. And you also know now that if you have a matrix that's not a square, like you have a matrix like this on the ACT, and they ask you what the determinant is, you can say there isn't one. Without even doing any math, you can answer that question correctly and move on. Because I have seen that problem. Not those particular numbers, but I have seen the matrix problems on the ACT in the past that has that. And it says, what is the determinant for this? And it gives you a list of numbers. And then none is an option. Well, now you know none is the right answer. So that's all we have for lesson 69. I will see you in lesson 70.